This is the 2024 deferred paper. It's paper 2 and it's question 2, the question on the circle. So in part A we're told that a circle S has centre 2, 4. So straight away I'll be labelling that. Good technique is to label points always, whether it's HK or XY, whatever it happens to be, to suit what you're given. In this case it's a centre, so it's HK. And there's a point on the circle. Now a point on the circle, any given point is XY, so we label this XY. Find the equation of the circle S. Okay, so we have our equation of a circle from the tables right here. So you just write it down and then you fill in what you know. So x minus h, so you have x, you have h, you have y and k. So fill all of those in, equals r squared. And you get 58 equals r squared, so r is the root of 58. Now that we have r, we can go back to the equation of the circle again, and it's x minus the centre, hk, which is 2, 4, up there. And we have the radius squared. R squared is now root 58 squared, which is 58. And that's it done. That's the equation of your circle. Part B. Here's a circle. We're told the centre is 9 minus 2. Using the diagram on the right, or otherwise, write down the coordinates of two other points that lie on the circle. Now there's a few ways we can go here. I mean, we can, for example, do a translation. You've got 3 minus 6 is mapped onto that, and if you translate by the same amount, you can get the point on the opposite part of the side of the diameter here. That only gives you 1 point, we need 2 points. So what we can do maybe is get the radius, first of all. And then any point that's that distance from the centre will be okay, because it'll be on the circle by definition. Right. So the radius is the distance formula. It's the distance between those 2 points, clearly, on the diagram. This is another exam technique, of course, here as well. That wasn't given to us, that radius line in the diagram. But a good technique from experience over the years of doing these questions is always fill in any hidden radius. So that's a perfect example of filling in a hidden radius. There's join up from there to there. Anyway, find the radius using the distance formula. Call that x1, y1 and x2, y2, and you get your radius, your distance, which is the radius, which is root 52. Now you can get the equation of the circle, because you need 2 things for the equation of any circle, the centre and the radius. The same as you need 2 things for a line, for example, point and slope. In a circle you need 2 things for the equation, you need centre and radius. So we have the centre, so fill in hk again. We have the radius, fill that in for r, and you have your equation of this circle. And the idea is that now any point that fits in there, so but you can try trial and error, put in a value for x, any value for x really. Well, not any value will work because it has to be on the circle, but we've got to work smartly here. So I'm going to bring this over here right now, and just by a few little observations, for example, if I drew my number line down here, it's 3 something, so that's 3 on the x-axis. That's lined up with 3. This is 9 something, so that's lined up with 9 on the x-axis. So if I pick some point in between, like 5 for example, well 5 something is definitely on the circle, if you think about it that way. So definitely if x is 5, we'll get an answer. And that's what I do, I just fill in 5 for x and see what pops out for y basically. So I fill in 5 and you work it all out here, and you get a value for y. It turns out this is squared. Now when you get to this stage, y plus 2 squared is 36. So you can, basically that means that y plus 2, be careful now, if it's squared, it's plus or minus 6. Because don't forget, minus 6 squared is also 36. So there's actually 2 answers. And you work them out separately, y plus 2, y is equal to 6 minus 2, and y equals minus 6 minus 2. And you get 4 or minus 8. So we've actually got 2 for the price of 1 here. We've actually got 2 points. We've got 5, 4, which is probably that point there. And we've also got, actually no, that's actually 5, 4 is probably up here now, and that's 5 minus 8. So we've got 2 points on the circle, 5 minus 8 and 5, 4. So there's the 2 points. That's it done. I just picked 5, but you can pick anything you want. Pick 4, pick 6, whatever you want. Just be smart about it. I mean, obviously if you pick 10 or 20 or something, it wouldn't be on the circle. So use the information you're given to be smart about this and pick a point that's actually on the circle. Okay? Right. Part C. This is a typical, what I call, make the diagram sweat type of question. And what I mean by that is, I find by experience with these questions, again, in all the exam papers over the years, you're given a diagram like this, you try and make the diagram work as hard as possible for you, so that you don't have to work, basically. That's the idea, or that's my recommended technique for this type of question. Happens an awful lot in circle questions. So again, we were given just a circle here. Now I wasn't, these are my own lines you see in blue, but the original circle we were given is the black circle here. And there's a point on the circle 0, 3, and there's other points G and H where it cuts the circle with the x-axis. Now, what did I do here? Well, as I said, make the diagram sweat. Fill in things that you know. Now, number 2 is fill in any missing radius. So, just by observation, from the centre to that tangent is a radius. Because that's a theorem. I mean, if you ever draw a tangent to a radius, it's always perpendicular to the radius, basically. So that's a known theorem. So that's the first thing. So we know now that that's perpendicular to the vertical. In other words, it's horizontal. That's a horizontal line now of length r. Here's another hidden radius. As I said, that's technique number 2, fill in any missing radius. There's a radius from here to here. That's also r. What else do we know for certain? Well, let's milk this a bit. The point 0.3. What can that help us with? Well, think about it. That means the height here is 3. So when it comes to the centre of the circle, we might not know the x value, but we definitely know the y value is 3, because that's the height of that line. So again, the diagram is working for us. We're not working as such. It's doing all the work for us without us doing any calculations so far. Now, something else is, how far across are we? What's the x value? Well, if that's the radius, that's the x. That's how far across we are on the x-axis also. So it's r across and 3 up. So now we know the centre is r3. Another tip is, whenever they ask for the equation of a circle, they're looking for 2 things really. What they really mean is find the centre and radius. Because once you have those 2 things, you can use the formula in the tables to get the equation. So whenever they ask for the equation in the exam, think about that. They're really looking for the centre and radius. That's what you have to find. Because once you've got that, those 2, you're finished, basically. You just plug into the formula. So if we could find those 2 things, well, we're nearly there. We have the centre, r and 3, kind of. We don't just know what r is. We have the radius, it's r. So look what's happened. We're just looking for one thing now, r. Because once we have r, we have the centre and we have the radius. And we've done all that without really doing any working out, as I said. It's all the diagram doing the work for us here. Make the diagram sweat is what I call it. Now, what else can we get from this? Something we haven't used yet. So we've used these pieces of information up here. We haven't used this line here yet. That it intersects the x-axis at G and H. In other words, that's a chord from G to H. And we're told the distance GH is 8 units. Now this brings to mind another theorem. There's a theorem which says, if you have a radius and a perpendicular chord, well, the radius bisects the chord. And that's what we have up here. I mean, again, this is obviously a perpendicular. If you come straight down perpendicular, that's a length of 3. And if you drop the perpendicular right there, well, if that's 8, it's 4 on each side. That's what the theorem says. And now look what we've got. We've got a very straightforward Pythagoras here. We've got a right angled triangle, 4 squared plus 3 squared is r squared. And there's the final step, because now once we have that, we can get r. And that means we have our centre and we have our radius. So the centre r3 is now 5, 3, and the radius is 5. And once you have that, you're finished. You're home and dry, because now it's just filling into the equation for the circle x minus h3 squared plus y minus k squared equals r squared. In this case, it's 5 squared. And that's what we were asked to find the equation of the circle. And that's the end of question 2. We'll now go on to question 3 in the next video.